Hello, my name is Rashmi Mishra, 19 BEC 1347, and today I will be talking on the topic Zerocash. This is a video assignment under the course Blockchain and Cryptocurrencies handled by Dr. P. Nityanandam. Introduction. Zerocash is a protocol that provides a decentralized cryptocurrency that is a privacy-preserving version of Bitcoin. It builds on the concept of zero coin and uses a cryptographic technique called zero-knowledge succinct non-iterative arguments of knowledge (ZK snarks), which are a way of making zero-knowledge proofs much more compact and efficient to verify. In Zerocash, users may pay one another directly via payment transactions that reveal neither the origin, destination, or the amount of payment. Zerocash improves on Zerocoin both in functionality, as Zerocoin only hides a payment's origin and not its destination or amount, and in efficiency, as Zerocash transactions are less than 1 KB and take less than 6 milliseconds to verify. How does Zerocash work? In Bitcoin, we know that a payment transaction consists of an origin address, destination address, and payment amount. These transactions are bundled into blocks and stored on a decentralized ledger called blockchain. Because blockchain is public, the history of all transactions can be viewed by anyone via the Bitcoin software or by visiting any blockchain monitoring service. While addresses are not explicitly tied to the user's real identities, several recent works have shown that the blockchain can be mined to learn information about the user's spending habits. Zerocash extends Bitcoin's protocol by adding new types of transactions that provide a separate privacy-preserving currency. The transactions reveal neither the payment's origin, destination, or amount. Zerocash creates a separate anonymous currency existing alongside a non-anonymous base currency, which we refer to as base coin. Each user can convert base coins into Zerocash coins, which we call zero coins. Users can then send zero coins to other users and split or merge zero coins they own in any way that preserves the total value. Users can also convert zero coins back into base coins, though in principle, this is not necessary as all payments can be directly made in terms of zero coins. Zero coin transactions. Zero coins functionality is realized by using two new types of transactions, namely mint transactions and pour transactions. Mint transactions allow a user to convert a specified number of non-anonymous bitcoins from some Bitcoin address into the same number of zero coins belonging to a specified Zerocash address. The Bitcoin transactions itself consist of a cryptographic commitment to a new coin, which specifies the coin's value, owner address, and unique serial number. The commitment is based on the SHA-256 hash function and hides only both the coin's value and owner address. Individual Zerocash nodes maintain a Merkle tree over all of the coin commitments seen up to that point in time. Any user can then demonstrate ownership of a coin commitment via its decommitted values as well as a short witness of the membership in the tree. Unfortunately, merely publishing this information as ownership proof is not private. Instead, to achieve privacy, we rely on a second type of transaction which allows a user to prove in zero knowledge that he knows such information. This transaction is called the pour transaction, which allows a user to make a private payment by consuming some number of coins owned by this user in order to produce new coins. Roughly, a pour transaction for up to 2 input coins and up to 2 output coins involves proving in zero knowledge that the user owns the 2 input coins. Each one of the input coin appears in some previous mint transaction or as the output coin of some previous pour transaction, and the total value of the input coins equals the total value of the output coins. The pour transaction consumes the input coins by revealing their serial numbers but does not reveal any other information such as the values of the input or output coins or the addresses of their owners. Optionally, the pour transactions can also input some non-anonymous bitcoins, output some non-anonymous bitcoins. This last feature can be used to transfer zero coins back into non-anonymous bitcoins or to pay transaction fee. Verifying Zerocash transactions. For a mint transaction, the commitment contained in it is constructed so that anyone can verify that the committed coin has the claimed value. For a poor transaction, anyone can verify the zero knowledge proof contained therein is valid. For efficiency, Zerocash does not use any zero knowledge proof but leverages zero knowledge succinct non-iterative arguments of knowledge (ZK-SNARK) systems, which are zero knowledge proofs that are particularly short and easy to verify. Specifically, Zerocash uses ZK-SNARKs constructed by SCIPR Lab. Such proofs are less than 300 bytes long and can be verified in only a few milliseconds. Some advantages of Zerocash are listed below. The overall efficiency of the system is improved to the point that it becomes possible to run the whole network without needing a base coin. All transactions can be done in a zero-knowledge manner. Zerocoin supports regular transactions for when you don't need unlinkability, augmented with computationally expensive transactions that are used only for mixing. The mixed transactions are of fixed denominations and splitting and merging of values can happen only in base coin. In Zerocash, that distinction is gone. The transaction amounts are now inside commitments and are no longer visible on the blockchain. Cryptographic proofs ensure that the splitting and merging are done correctly and that users can't create Zerocash out of thin air. Zerocash is immune to side-channel attacks against mixing because the public ledger no longer contains transaction amounts. The ability to run as an entirely untraceable system of transactions puts Zerocash in a category of its own as far as anonymity and privacy are concerned. There is a catch though. It is that it requires an enormous set of public parameters, more than a gigabyte long, to set up the zero-knowledge proof system. To generate these public parameters, Zerocash requires random and secret inputs, and if anyone knows these secret inputs, it compromises the security of the system by enabling undetectable double spends. As of 2015, no one knows exactly how to set up the system in practice in a sufficiently trustworthy way. To date, ZK snarks have not been used in practice. In conclusion, we looked at Zerocash. Due to its improved efficiency, Zerocash can be run as a fully untraceable and not just anonymous cryptocurrency. However, like Zerocoin, Zerocash is not Bitcoin compatible. Worse, it requires a complex setup process that the community is still figuring out how best to accomplish. Thank you.